I'm Dan Dennis,
And I'm Dallin Schiffman.
and this is our final project for ECE 3710.
It's Microcontrollers. We built a automated chessboard. It uses an electromagnet to move chess pieces for you as you go.
So each piece has a neodymium magnet on the bottom of it, and that way when the electromagnet activates, it can pick up each piece and move it.
We added felt to the bottom of each chess piece just to help reduce friction and make sure to help reduce any error in sliding and having the magnet lose the chess piece in motion.
And then in order to control everything, we have the Nucleo board as well as LCD and the keypad. We just built an enclosure for the keypad, but underneath everything, the keypad is sitting under that.
All the wires are housed inside of this, and we have a motor on a track on the inside as well as that, and we'll show you that in a little bit. When you power on the chessboard, you're given the options of manual game or auto game by pressing A or B. So if we push A, it's going to start going to 0 all the way up here in the corner. That's A0, A1. And then we're going to let it get all the way there, and then we'll put in some inputs to demonstrate it taking specific pieces to certain places. So then once it's at A1, it'll say ready when you are. So let's move the pawn right here from B2 to B4. And then as you press it, it has feedback telling you which buttons you've pressed. Now it's going to it tells you it's grabbing the piece at B2. And so you'll see nothing move, and then once this screen changes to moving piece to B4, you see the piece moving by its own, like Harry Potter. Now this works on any chess piece, but something also that it does is it keeps track of where we move the pieces on the board. So even though this is not a valid move, let's move this pawn to this space, and the board will recognize it as a kill move, and it'll say killing a piece at B4 once we get there. So that if we were to select auto game, we would just press B, and you can see it starts going to 0 again, and then it will start moving the pieces as it is. We have a sped up montage of it moving it because the pieces move somewhat slow, so a full game took over an hour. So we'll speed that up, and you'll see that here next.
While the auto game is running, I'll do a quick recap. We proposed our project to be able to make an automatic chessboard that will move the pieces for you just through an input from a keypad, which we were able to accomplish. We also proposed that we wanted to have a saved game in there as well that you could also opt to choose to watch instead of play. We are also able to accomplish that. So enjoy the rest of this auto game.
So now we're going to kind of show you what's inside of the chessboard making it run. So here we have on the side panel, we just have some wood, and we drilled out holes to allow us to insert these metal rods, which it runs off of. And this sheet right here, it's just a sheet of acrylic that we taped some paper to the underside to get that design. And then in here we have 2 sets of timing belts and 2 stepper motors. These are actually just the stepper motors from the lab that we had. And these will run in either direction, which will move the pieces.
Now, a big problem we had while we were coding everything in is we didn't know how long we needed to run each motor for it to go one space. So while we were going down here, we tested it until we found a constant that would run the motor a specific number of times to get from the middle of one space to the middle of the next space. And we saved that as a constant inside the program. Now, we also realized that, can I have another piece? That as you're moving a piece from one place to another, we can't just move them straight because then it will hit other pieces in the process. So what we programmed in is we had it offset by half a space and then move to whatever its desired location is and then fix the offset at the end.
Another huge issue that we faced was where to put all the wires. Originally we just had them sitting flat against here, but what ended up happening, we would get the wire kinking up here and here as it was moving by. So we built these little fans that should help the wire move back and forth as it stays flat.
And feed away from the track so it doesn't get caught.
And at the end of it, it was still getting stuck. So down here, I ended up raising up the whole board about 1 centimeter. And that helped with the wire management significantly. So this project required a lot of custom pieces, so we decided to 3D print a lot of them, and we just designed them using Tinkercad. So here we have modeled the wood and the rails and the cart system for the linear motion here. And then we have the keypad modeled here, and the chess pieces as well, with holes cut out on the bottoms. Now, if we were to do this project again, I would definitely buy new stepper motors, because the ones that came in the lab kit, they were kind of weak, they didn't have very much torque, and they were also kind of slow. That's why we had to speed up the video of the chess pieces moving, because of how slow they were.
And because of that, it was having insufficient amps to help support the motors going, so we actually ended up using an external power source that we ran through the microcontroller so that we can get the power we needed.